And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, roger, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. It's orange!
25. Oh my god! Oh my god!
Décollage.
What is it?
Put that in the big bag, you know.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Good evening, everyone. You are taking a live look right now at Space Launch Complex 40 at the Cape Canaveral Space Force Station, where we are looking at Falcon 9 ready to launch 22 more Starlink V2 mini satellites. But this is not just your ordinary Starlink, I promise you that. We've got some really fun facts about this mission that we will get to momentarily. But first, I love seeing all those 5x5s in chat. And for those of you that know me, and for those who don't, I am Sawyer Rosenstein. I will be your host for this evening, the host with the most puns, hopefully. And joining me tonight is Trevor Sesnick. Trevor, how are you doing?
You know, Sawyer, I'm doing really well. It's exciting that we're on these 17th flights and have some more cool stats that I'm excited to talk to you all about.
Oh, it's a fun one. And also fun tonight, joining us on Field Comms is Julia Bergeron. Julia, how's it going tonight?
Well, good evening, Sawyer. I'm up here on the Max Brewer Bridge. It's a little bit breezy, but mostly clear, and I'm excited for a second 17th flight tonight.
Oh, yes, you may be at Max Brewer, but Max Evans will be the one at the press site bringing you the video feed that you're seeing at the moment. And the one who's bringing all of this to you is Pat O, who's in the back pushing the buttons, pulling the levers, and making all the hamsters turn in their wheels so this video gets to you. Now, we mentioned that this is not just your ordinary Starlink. I say that a bunch, but this one has quite a few historic bits to it. As mentioned, this will be the second booster to hit 17 flights. This will be the 200th reflight of a SpaceX booster, and SpaceX's 69th launch, nice, of the year. Trevor, do you mind just breaking down all the details about this mission for us?
Yeah, of course. So as you said, this will be launching 22 Starlink V2 mini satellites, which will be placed into an initial 284 by 294 kilometer orbit, inclined 43 degrees. The satellites will spend the coming weeks and months raising their orbits up into the operational 530 kilometer circular orbit at 43 degrees. The booster, as you said, is flying for its 17th time, which Julia will talk more about in a second. And after launch, it will attempt to land on SpaceX's drone ship Just Read the Instructions, which will be stationed approximately 618 kilometers downrange. Another cool thing is, following having some work done on it for the past few months, this will be Bob's return mission. So Doug has been working overtime for the last few weeks, but on this mission, Bob will attempt to recover both fairing halves from the water, roughly 676 kilometers downrange. And then, as you said, this will be SpaceX's 200th reflight of a booster and the 258th launch of a Falcon 9. So we're coming up on, wow, what percentage is that? That's almost 80% of all Falcon 9 flights being on flight-proven boosters.
Yeah, that number's insane. And should say Bob is back again, just from the repairs. He's already been out once, kind of get his sea legs back, and now supporting again tonight. So, as we mentioned, again, 203 flights, 17th time this booster has flown. There was a little confusion about which booster would be flying tonight, but it is still a 17th flight of a booster. Julia, do you mind helping us break down what booster we're talking about tonight and its path to today?
Well, certainly. Now, as Sawyer said, last launch we thought it was 1060, but it did turn out to be 1058, which SpaceX cleared up basically while they were broadcasting. So, yay! It is currently 1058 in Port Canaveral, and back to 1060. We started off launching 1060 June 30th, 2020, with the GPS 3-3 mission. From there, we went on to two Starlinks, then Turksat 5A. 1, 2, 3. Oh my gosh, of course, Starlinks, right? 3 more Starlinks. Transporter 2, which was, of course, a landing zone 1 landing. Starlink. Wow. You see a trend here, right? 1, 2 more Starlinks. Then we break it up with a Galaxy 33 transporter Starlink, and we are back to another Starlink tonight, which shows how do we best test these boosters that are in the older ages, hopefully to at least 20 launches. We do it with Starlink missions, which are lower risk for the company.
I'm just going to interrupt you here a quick second before I throw another question to you. I've started propellant load for tonight's launch according to SpaceX, and all systems and weather are currently reported go, which goes along with the question I was about to ask you, Julia, of how's the weather looking where you are?
According to Max, the weather is chilly. For us in Florida, it is 75 with a light breeze. The closer you are to the coast, it is a little bit muggier, which means it feels a little cooler. But it's a beautiful evening. There is a half moon, a few stars in the sky, maybe some wisps, but better than the last launch for sure for viewing.
Yeah, last one, for those who didn't get to see it, kind of went straight into the clouds, and I can say for the people that were southeast of the launch along Florida's coast, it was pouring rain here, so did not get to actually see it. A reminder, if you have any questions, you can tag us at NASASpaceflight, and we will do our very best to answer them about this mission, this vehicle, the historic moments, which, by the way, with the countdown now underway, this is also set to make more history in that this will be SpaceX's third consecutive launch, scheduled to launch at 11:38 p.m. Eastern Time. We had 11:38 and 20 seconds, then 11:38 and 10 seconds, and now 11:38 and 30 seconds. But who's counting? Except for the clock in the top left of your screen. We also already have some support coming in. Eric Souter, go back to the original T0 time. Thank you for becoming a Pad Rat member. And look at this generous support from John Dopker, gifting 10 Red Team memberships. But wait, there's more. Throw in a Bideford here with 10 Red Team memberships gifted as well. Thank you very much for all that. And of course, if you got one of those gifted memberships, please make sure to thank whoever gifted it to you if you haven't already. And Chuck Oak, thank you for becoming a Red Team member. Now, before we continue on, I do want to address something here. We did have a report, and I know some of you have already mentioned it in chat, about some 200 Starlink satellites kind of crashing and burning. Trevor, from what we know now, that is false, correct?
Yeah, that is correct. So if you look at Jonathan McDowell's Starlink page, and he goes through and pretty much after every launch and everything updates the amount of satellites in orbit, exactly what phase of their mission they're in, whether they're raising their orbit or whatnot, you'll notice that this story is not true. And right, obviously they have been deorbiting some over the past few months, but nowhere near this 200 number that came up earlier today.
There we go. And just wanted to make sure that we clarified that for everybody who was discussing it just before we went live as well. Here's an interesting question. Julia, I'll put this one to you. What does the 6-18 stand for in Starlink 6-18? And I'll let you group that one up yourself.
Well, we've gone through quite a few different numbering systems as I was going through photos. I was like, wow, that was L1 dash what? Yeah.
They started off as just L's. It was like L19.
Yeah, L. Yeah, it was kind of crazy.
So your bad mission to bring up. That was the last landing failure. Starlink V1.0 L19.
Maybe discussing that
Ouch.
later. So
Oh my. So basically, they're Starlink groups, meaning correct me if I'm wrong, Sawyer, because to me it's just these numbering systems are a way to keep things straight in my files. But it's basically we launch a different group of Starlinks from here than we launched from Vandenberg. So we launch group 6s, correct? And Vandy's been launching group 7.
they just started launching their Group 7. A lot of it also has to do with where it's going in orbit, too. That's part of it. So like you mentioned, the Dash 18 means it's the 18th one of the Group 6. A part of that,
Right.
we really started using the Group 6 mainly for the V2 minis, and that's kind of the shell they're going into, right, Trevor?
Yeah, that is correct. So there are 5 different shells for the Starlink V1 constellation, where the Starlink L launches that we were just discussing correspond to the first shell. And then later they switched over to this group naming scheme where it's Starlink Group X-Y, where X is the shell that they're targeting and Y is the launch number. But the launch number is, I guess mission number is a better way of phrasing it because it's not consecutive at all. So for example, sometimes you'll see like, I believe 6-17 may have launched before, so like 6-16 or something like that. The point is they're not always in order. So there are 5 of those shells for V1, and you are correct that shell 6 is the first shell of the V2 mini satellites.
There you go. And to mark off your bingo cards, that goes all the way back to the Space Shuttle program, if you think of the naming of some of those missions. Later on they were STS-130 and so on, but early on, they were originally given a number, 2-number system and a letter. So that would be, let's say, STS-51J. That would mean it's supposed to launch in 1985. It will launch from the East Coast. They didn't get to the Vandenberg launches, so they were all the ones. And then the letter was what number it was supposed to be that year. We've had launches with a 5 in front of them that launched before Challenger in 1986. So it was basically just they got the number, they got the naming, and wherever they ended up in the schedule, they kept the same number and naming, just to not make it confusing internally, but make it very confusing externally. Here's another question that kind of goes along with this, Trevor, and I'll put this one for you. Mark asking, it seems like all the Starlink launches for some time have been at night. Why is that? And I'm sure a lot of people have been watching all these, including us hosting it, are wondering why as well.
Yeah, that's a really good question. So there are kind of 2 parts to this answer. So the first is that SpaceX is targeting a very specific plane in orbit. So they are launching into this 43-degree orbit at 284 by 294 kilometers. But then, obviously those satellites go around the Earth every 90 minutes or so. So there's also a specific point in that plane where they're trying to target so that they'll be spaced out relative to the other satellites correctly. So part of it is orbital mechanics, but the larger part for these low Earth orbit missions is that during the summer months, weather is generally a little bit better at night and allows them to continue doing work on the launch pad during the day. Because as we see from this crane in front of the vehicle, they are starting to build the Slick 40 crew access tower. So between those 3 things, the weather, work being done, and orbital mechanics, it just kind of has pushed all of the launches to take place at night. And even more weirdly, all at the exact same time the Sawyer was mentioning earlier.
Yeah, keeping in mind that this one was originally supposed to launch shortly after 9 p.m., but delays have pushed it to later in the window, which there's typically about a 4-hour launch window for these, although SpaceX usually aims for the first T0 about an hour or so into it, and then they have backup times that are set. It's not like they go every 5 minutes or there's something off, they can wait just a couple of minutes. They have set times, and part of the reason for that may also be because of what are called cutouts in the window. Basically, there's a satellite overhead, you don't want to launch directly into it, so you wait for it to pass overhead before you launch, in the simplest terms. my goodness, the gifting subs keep coming in. Holy cow, Apocalypse Cow. Sorry, not Holy Cow, Apocalypse Cow. Thank you for gifting 10 Red Team memberships. Sorry, I'm proud of myself for the first one of the night there. Multi-Space Industry is a common name that we see here. Thank you for gifting 5 Red Team memberships. And James gifting 5 Red Team memberships as well. Really appreciate that. And more support coming in from John Dopker here saying, got to see my second Starlink train this past Thursday. And seeing it again tonight, a bit more spread out. Nice. I mean, I've never gotten to see a Starlink train. Julie, have you ever seen one?
I did early in the Starlink launches, more so before they started adapting them to be a little bit more sky friendly for the star chasers, shall we say. It's kind of cool.
I've had them on my calendar of when they'll pass overhead occasionally, and I never actually go out and see it. I really need to change that. But yeah, you can go out and see the trains fly overhead. They are definitely dimmer than they used to be, which part of that is also down to the design of them. These newer ones, they intentionally make them darker and less reflective of sunlight to try and be less of a burden on ground-based astronomers, as they typically, as many as there are now especially, will fly through some of their imagery that they're trying to catch, especially since most of those have to be done in sort of a long duration, almost streak in a way. And more gifted Red Team memberships. I'm not Jack. I don't break as easily. I don't think. Molly Merriams, thank you very much for gifting 10 Red Team memberships as well. Holy Toledo, Ohio. Except this is Cape Canaveral, Florida. But you know what I mean. The generosity is very much appreciated. Thank you, thank you. Here's a question, Trevor. I'll put this one to you, and I don't know if we know it exactly, but I'm sure there's a spreadsheet somewhere. James asking, what's the average lifespan of a Starlink satellite before they end up deorbiting?
Yeah, that's a good question, and I think the best answer is we don't fully know yet, because the initial satellites that SpaceX launched are still up in orbit. However, if I remember correctly, SpaceX was expecting roughly a 5-year lifespan on them before they run out of propellant.
Right, and they're also in such an orbit that eventually they will just deorbit on their own, because for those who don't know, that's actually a requirement now for every single satellite launched. You must have a way to dispose of it when it's done with its active lifespan. So for Starlink, they do have the small thrusters on board, but if they completely run out of propellant or something breaks, they're in a low enough orbit that over time they will decay enough that they burn up and are destroyed to help keep the sky a little bit clearer. And for those that can't, they have something called a graveyard orbit, where they will literally put it into an orbit that's specifically designed for garbage. So it's basically the sky fill instead of the landfill in that particular orbital range there. Now we are getting really close to not just any vent, but the best vent. And before we get to that, a lot of times the weather will impact kind of if we can see that vent or not. Julia, how's the wind at least looking there right now? And also humidity/bug report.
A bridge. I'm fortunate. I don't have bugs. There's, like I said earlier, just a slight breeze. It's actually a very, very welcome, nice night here on the Space Coast.
That is nice to hear. We're also getting a report not from the field, aka Jack, but from Max, who's over at the press site in the field, saying that there is next to no wind currently at the press site. The flag is dead still, and you can kind of see that the little outline of the bushes right near that rightmost tower. You could see it's just barely moving, and the weather is looking really good there. We are now T-minus 21 minutes away. If we can, let's take a look at where we are so far in the countdown as we approach 30 seconds away from one of our favorite moments here. So we had the go for launch. Stage 1 has been getting RP1, which is rocket propellant 1, or refined kerosene, as well as the liquid oxygen, the LOXygen, or as you see there, LOX, loaded into it. Meanwhile, the second stage has only been getting RP1 loaded so far, and that leads us to where we are about to be in about 5 seconds, and that is what you see labeled there as the best vent, which we call the T-minus 20-minute vent, beginning directly on time there. Trevor, what's happening besides the little plume of smoke on the right there?
Well, to be very clear, that's not smoke. That's just vapors. And what that is, as you just mentioned, the RP1 load on the second stage has now completed. And there's only one line that fuels the second stage through the transporter erector, which you can see on the right of the vehicle. So what SpaceX has to do is purge the line to make sure that it's clear of RP1 and make sure that it's cold ahead of liquid oxygen load, which begins at T-minus 16 minutes. So this is the venting from them doing that purge, and it's just liquid nitrogen that is boiled, so gaseous nitrogen.
Right, and again, you'll know that liquid oxygen load has started on the second stage when you see that venting actually come to a stop there. So it's another good launch indicator of where we're at. Let's take a few more questions here. Kurt Gullacher. Trevor, I'll put this, Julia, I'll give this one to you. Is there any chance of a lunar jellyfish tonight?
Probably no. We only have about a half moon. It's starting to set in the west. Oh, I mean, I've been wrong before, but I don't think we're going to have those conditions tonight.
I mean, we can hope, but yeah,
We can hope, but the rocket's going to be going away from, because it's going southeasterly. We can hope. I'll give you hope.
There we go. That means you'll just have to stay and watch to find out, right?
That's right.
There
We're
you
not
go.
that far away from launch. Just stay with us.
Exactly. It's, again, we're at the best vent, so it only gets better from here. At least that's what I say to myself for these late night ones. Anyway, along those lines, Bloodhound asking, and I know we showed the graphic, I believe, once, but you mentioned it there, Julia. What's the launch trajectory for tonight?
It's what we've had for, I think, this whole group, southeasterly, which is actually quite a pretty trajectory if you're down in areas like Jetty Park or a little bit farther south down the beach. You get, oh, hello, car. A very nice view of that launch for a lot longer because it's coming towards you. So we've been embracing southeasterly.
Yeah, Sherry Downs Park, down in Cocoa, even probably to along the beach areas along Patrick Space Force Base, you can get a really nice long view of it, and you still will get a view of it, essentially, if you're anywhere south of Cape Canaveral, particularly to the east. So going down the line, obviously you've got Brevard, Indian River, St. Lucie counties, Martin County, Palm Beach County, Broward, Miami-Dade, all of those, even some of the more inland ones like Okeechobee, you'll probably get to see some of it. Ooh, testing my Florida geography there for a second. The support continues to come in. It's fantastic, very fantastic. John Dopker with a great question here saying, Earth weather can be a pain. Trevor, I'll put this one to you, but how often does space weather cause delays?
It's not that common, but it's also not rare. For example, just the other day on Rocket Lab's ill-fated launch, they had a hold before their launch attempt due to solar activity. And then we also saw, I believe on the order of a year ago now, there was some elevated solar activity which didn't scrub the SpaceX launch that caused the atmosphere to somehow get thicker. I don't really understand the physics of it up at the deployment altitude. So SpaceX lost a number of satellites early. But it's not that common, but it's also not rare.
What degree are you going for?
I'm a mathematician at this point, okay?
Not physics, okay. Fair
I
enough.
still am in a physics program, but let's not think about that.
No, let's forget about schooling for a little bit here and just focus on more generous support here. Apocalypse Cow, again, gifting 10 red team memberships. Wow. Again, I keep saying holy cow. It's not even meant as a pun. It's just very impressive. Thank you. Jim Cavett gifting a red team membership. Revelation Motovlog becoming a Padrat member. And Bideford buying up the pun tokens here. Where are the puns, Sawyer? Come on, bring them on. All right. I may have to Starlink a few together for you guys then to make up for it, so we'll see.
Please do.
Oh boy. As long as I don't refly puns, I think we're fine. I will reply to questions. We will refly boosters. But, yeah. I see Max's disdain already in the back channel for that. You're welcome, everybody. Along those lines, while we're talking about the reflight, I think it's worth bringing up again the historic natures, shall we say, of this mission. Again, a record 69th launch, nice, for SpaceX so far this year. This will be the second booster to reach 17 flights, the third launch in a row, scheduled to launch at 11:38 p.m. Eastern Time, as is currently, and the 200th reflight of a booster. But what does it take to get to this point? How did we go from our first landing way back in 2015 to today? That's a good question. It's a good thing I prepared a video just for that occasion tonight. Tonight's Starlink 6-18 mission will mark the 200th reflight of a SpaceX booster. But how did we get here? Step 1 was to prove a booster could come back and land. It started off with a bang. Okay, a bunch of bangs on barges in the ocean. The first successful booster landing was back on December 22nd, 2015, as B-1019 landed back at Landing Zone 1 at the then Cape Canaveral Air Force Station. Talk about a holiday gift. That booster is now on permanent display at SpaceX headquarters in Hawthorne, California. The first successful landing at sea took a little longer. On April 8, 2016, after successfully delivering a cargo Dragon capsule to the International Space Station, Booster 1021 landed upright on Of Course I Still Love You, the drone ship, around 9 minutes after taking off. That booster made history again 1 year later, when on March 30th, 2017, it became the first booster to fly for a second time, delivering the SES-10 mission to orbit and once again touching down on Of Course I Still Love You. That booster is now on display inside the Gateway exhibit at the Kennedy Space Center Visitor Complex. Since then, multiple boosters have been flown over and over again. The last time SpaceX missed a landing was back in February of 2021, when B-1059 encountered some heat damage, which forced one of the engines to shut down before touchdown. On Starlink 6-17, SpaceX set a record when B-1058 flew for a 17th time. Now, B-1060 is looking to do the same tonight on its 17th launch, as we mentioned, marking reflight number 200 for SpaceX. There you go. Short little history, and it was a Falcon Heavy sidecore, that was at 30, that is at Gateway. It's 1023. 1021 is still hanging out at Slick 40, just chilling. Julia, you were there. We saw some of the pictures for all of the recovery at the end there. What's it like seeing it from its clean state to now?
It's absolutely crazy. Honestly, today I realized just how much 1058 is so dark. It just kind of blends in with the drone ship and the cargo ship around it. And if you are passing by there at night or even looking on our live views, I kid you not, it just ghosts into the night now. So yeah, it's kind of crazy when we see a pristine white booster anymore, which I bet you, Sawyer, another question that's going to come up is, why don't they wash these boosters?
That's true, especially since we saw the one at Hawthorne that's perfectly clean even after it flew once.
I think there was some refurbishment there. The long and short of it is, if you want to rapidly reuse, then why take the time to clean, right? And the other thing is that takes more labor and honestly also would generate waste because you can't just wipe that off with soap and water. You actually have to use things like isopropyl alcohol to remove that soot So it's just easier to leave it alone. And if they have to modify the flight profile just slightly to accommodate that, they will. But so far, it doesn't seem that there's been any major modifications to accommodate the added weight.
There you go. And I know we've been getting, I saw a question just a moment ago asking about basically, will there be another expendable Falcon 9 booster? And we've seen them actually this year so far.
Yes, we have. This year on, sorry, I'm looking at my spreadsheet now. End of last year, we saw Galaxy 31 and 32 expended on, sadly, B1051, which I think hurt a lot of us. And then we've seen some Falcon Heavy center cores expended this year on the EchoStar 3 mission, on USSF 67, and Viasat 3. So they still are expending Falcon 9s, but it definitely isn't common.
No, but what is common is our Florida team getting some spectacular photos of some of those expendable boosters and the reflown ones, and we have them now as metal prints at shop.nasaspaceflight.com. Talking about Falcon Heavy, how it's a mix of reuse and expendable ones, we have some awesome Falcon Heavy prints in the shop, in fact, as you can see right there. I mean, just look at that 27 engine power. You'd never know that some of those had flown previously and how gorgeous it still is from all of that. And again, these are all available at shop.nasaspaceflight.com, and all of them come with a message from the photographer about them, especially our newer ones, and you can add a message as well. If you get anything from the shop while we are live during the stream, you can add a message if you so choose that will show up on our special panel here so that we can read it on air. I like to think that was a pretty smooth transition on that one.
They always are, Sawyer.
Maybe not as smooth as the surface of the boosters with all that soot, but you know. All right, I know that joke was actually pretty rough, not smooth.
Oh my gosh.
Well, I say that because we have Anna Gallin here from Miami saying pun credits for Sawyer, as well as Astro Knucklehead, excuse me. Sorry. Sawyer pun token gifted. I had to do it because I took my dog named Shark to the beach. I hope your dog doesn't bite. Oh, I'm on a roll here and my brakes are locked. Anyway, Rocket Prophet, thank you for gifting 10.
Wouldn't that mean that you're not on a roll? Because doesn't rolling mean that you're stationary, like the bottom of the tire is stationary relative to the surface, and if your brakes are on, then that's not the case, so you're not rolling?
That's the pun, Trevor. That's the pun. Rocket Prophet gifting 10 Red Team memberships. Joe Pastrito gifting 5 Red Team memberships as well, and James gifting 5 Red Team memberships. Holy cannoli! And now I'm hungry for dessert, but thank you all for the generous support. It really means a lot. And then another question of support here coming in from Revelation Motovlog saying, will I be able to see anything from Maryland? And unfortunately, I don't think so. Typically, there's only one type of launch that you can see if it goes northeast. Right, Trevor?
Yeah, so as we mentioned before, today's launch is going southeast, and so you won't be able to see it. However, on a lot of the ISS missions and some of the Starlink missions that head up northeast, you would have a much better chance of being able to see it.
Exactly. Yeah, pretty much all the ISS missions, you'll get a great view because either it goes northeast from the Cape or it launches out of Wallops Island, Virginia, which also gives a great view along the east coast there. So appreciate that. And Barb T, thank you for becoming a PadRat member. Now here's a question for Julia. Logan Adamson is asking, since we saw all the landings and everything there in the video, especially on the drone ships, how is the booster secured to the drone ship after landing?
It's magic. No, it's not magic. There's actually, it's called Octograbber, or I think they officially, it doesn't matter. We call it Octograbber, and it is actually robotically operated, and it comes out of a garage on the drone ship and scoots underneath the booster, thanks to GoPro cameras. think of it as like a mini tank. Not only is it low to the ground, but it is heavy. And what it does is those four arms grab onto the same clamp, same hold points that the launch pad actually uses to hold the rocket down before launch. And that alone, no magnets, no magic, just a mini tank, hold it to the drone ship in most weather conditions at sea.
Yeah, we've seen a few kind of tip a little bit, but yeah, when it works, it's such a cool piece of technology. And again, you can see it sometimes when we pan up and down when the boosters return into the port on our Space Coast live cameras, which you can see 24/7 right here on NASASpaceflight 2. We are now under 5 minutes away from liftoff here. Julia, if you need to set up some cameras, we'll let you go ahead and do that. And we will talk to you after launch.
Thank you so much, everybody. Enjoy.
Oh, I'm sure we will. So now, as we come up at the T-minus 4 minute mark or so, that is when the retraction will happen of that strong backed, the TE, on the right side of your screen. That moves back just a couple of degrees, and when we get to T0, it will completely throw back so that it's away from the rocket itself. That's what's been providing it with all of the propellants and oxidizers on board, as well as providing power and air conditioning and other items to the satellites on board inside that payload fairing on top as well, which hopefully we'll find out if those payload fairings are reflown or not, although they do look a bit on the cleaner side, Trevor.
Yeah, it's hard to tell with how dark it is, but definitely not as flight proven as some of the other fairings that we've seen.
And with the quality of X streaming. I mean, what? I'm sorry. I joke. Let's get serious now as we get into this final part of the count here. So you can see kind of that venting a little bit right now near the interstage area. That's that black portion. There's another vent that is expected in about a minute, Trevor. What's that one for?
Yeah, so in a few minutes we'll see a series of things happen. First of all, the liquid oxygen load on the second stage will finish up, and we will see a similar vent to what we saw at T-minus 20 minutes and 20 seconds of that line being purged. Additionally, at the base of the vehicle, sooner than later, the engines will begin being I guess they already began being chilled a few minutes ago, and sometimes some vapors are visible from that, but generally not really, and that's when SpaceX runs a little bit of liquid oxygen through the turbines of all 9 Merlin engines to make sure that they're chilled down ahead of full propellant load at T-minus 3 seconds or so when engines are commanded to start up. And then at T-minus 2 minutes, as I said, stage 2 LOX load will be completed, and then at T-minus 1 minute, Falcon 9 will enter startup and pressurize its tanks for flight.
There you go. And at this point, we have confirmation that Stage 1 LOX load is complete. As mentioned, the next big thing we're waiting for will be the Stage 2 LOX load complete call, along with the vent that kind of indicates that. After that, it's all up to the launch director once everything's pressurized for flight. They will give the go or no go. And then the engine ignition process starts at T-minus 3 seconds with a green flash. That is a material called TTEB that is used to help ignite all 9 Merlin 1D engines at the base of Booster 1060 tonight. And so far, everything continues to count down as we reach under T-minus 2 minutes now and counting to the scheduled liftoff time of 11:38 p.m. Eastern Time. A reminder, on board 22 Starlink V2 mini satellites on the 6-18 mission heading into low Earth orbit. And there is that vent that we were just talking about as we hit 90 seconds to liftoff. We also have confirmation verbally that Stage 2 LOX load is complete, and the visual confirmation on the screen as the final purge of that line is underway right now on the right side of your screen. Before we get into the nitty-gritty part of the count here, I do want to point out that once we get to liftoff, we will be absolutely quiet, but it will be a bit of a delay before you hear the sound. That's not us pausing it or anything. That is just the delay from the speed of sound going from the rocket to where our microphones are located at the press site. We are now 1 minute away from liftoff. At this point, Falcon 9 enters startup, which means the onboard computers have now taken control of the vehicle, and all tanks on board are now pressurized to flight pressures. And we have confirmation of Falcon 9 in startup. The next thing we'll wait for is the call out from the launch director that we are go for launch. This is the essentially final stopping point if anything's going wrong by a person, but so far it is not. We have confirmation go for launch as we hit 30 seconds and counting. We are now 20 seconds away from this booster launching for its 17th flight. We're now coming up on T-minus 10 seconds. T-minus 8, 7, 6, 5. Keep an eye out at the base of the rocket for that green flash as we wait for engine ignition, which we have there. 2, 1, 0, and liftoff. Liftoff of Falcon 9 on a tying record-setting 17th flight for this booster. Go, Starlink V2, go. We just had a gorgeous view there, what looks like around a vapor cone as the vehicle gets ready to pass through the speed of sound, and as the vehicle now enters max Q, that is maximum aerodynamic pressure being pushed down onto the vehicle at this point of flight. That is something you don't get to see very often. A great capture there of that ring kind of flying off the back there. Absolutely beautiful so far. And now you'll start to see the individual engines as the atmosphere gets thinner. The engine exhaust starts to spread out more, which allows you to see more of the individual engines there. There's no change whatsoever in the gimbaling or the adjustment of how those engines are. It's just the thinner the air, the wider it looks. We're now about 30 seconds away from a couple events happening in rapid succession here. The first one, at T plus 2 minutes and 25 seconds, is MECO, or main engine cutoff. That's followed a few seconds later by first and second stage separation. So the two stages will separate, and after that, the second stage engine will ignite. That is called SES1, or second engine start 1, when the Merlin vacuum engine ignites. So those should be happening momentarily. Reminder, our cameras are a little bit ahead of the SpaceX feed. So as you saw on the left from our cameras, we had MECO. You'll see it again from the SpaceX feed momentarily. And that will be followed by stage separation. And there we go. And then we should have SES1, second engine start. And there we go. We have ignition of that Merlin vacuum engine. And it appears as if the stiffener ring has also broken away. For those who don't know, the stiffener ring is basically what holds the shape of that engine bell the way it is until it gets into the thinner parts of the atmosphere and space. There it goes. Trevor, look at that view on the left.
I always love this view of the grid fin slowly deploying in the light of the second stage and whatever else is providing light. It's always so gorgeous. As well as that shot of the fairing on the right that's about to deploy, and there it goes. Always an awesome shot.
Exactly, and a reminder, those fairings are actually recovered to be flown again. Those are expected to land about 676 kilometers or so downrange and be picked up by Bob, one of the recovery ships. So now at this point, everything will continue in flight for that second stage. And on the first stage, you can take a look at the data there in the bottom left. The speed may be going down, but you'll notice the altitude is still increasing on that first stage. That's because it still has that forward momentum. And as it continues to go up, it will drop in speed, but you'll notice a point where the altitude will just stop. It will stay pretty much where it is. That is what's called apogee, the highest point in its orbit, or in this case, suborbital trajectory. After that, you will start to see the altitude decrease and the speed increase, kind of in reverse. And that's why we have those two burns that are coming up, right, Trevor?
Yes, that is correct. So the first burn, called the entry burn, will start by igniting the single center engine and then ignite the two outer engines, E1 and E5, and that will slow down the vehicle and protect it from some of the heats of reentry. It's literally fighting fire with fire, as Sawyer always likes to say, which I think is a very cool way of describing it. And then a few minutes later, the second burn will be the landing burn, which the booster will just ignite its center E9 engine to attempt to land softly on just read the instructions, and that's coming up in about 3 minutes.
There you go. In the meantime, though, we should have that fighting fire with fire burn, as you were mentioning there, coming up in just over a minute from now. And you could also see those little puffs on the left there of the cold gas thrusters. So they kind of cut away from it. But how is it steering itself, Trevor?
Yeah, it's a great question. So currently the booster is right at 102 kilometers or so. So that is far too high for the grid fins to have any real control authority because the atmosphere is just not dense enough. So during this phase of the flight, the booster has onboard gas thrusters, which I believe are a mix of nitrogen and possibly helium, but I don't think SpaceX has said officially what the gas is, but I believe it's both. And those are just stored at high pressures in COPVs, and then they slowly vent them a little bit and in very quick pulses to control the vehicle. And then as the vehicle descends into the atmosphere, primarily after the entry burn, the atmosphere starts getting significantly thicker, meaning the grid fins have more control authority. So then you'll see the grid fins starting to move to orient the vehicle and pitch it for the landing burn and landing.
And for now, you'll see the entry burn on the left side of your screen there. And again, for those wondering, that's why the boosters get so sooty after, in this case, 17 flights and counting. Basically, it's going through its own exhaust plume, and the exhaust plume consists of RP1, which is a refined form of kerosene. Kerosene being carbon-based, you get soot. And as you can see, quite sooty on the camera there, as we get the end of that entry burn, which usually lasts about 20 seconds, and it looks like it was about right on time. So again, the next thing that we'll keep an eye out for will be the landing burn, where it will attempt to land on the drone ship, just read the instructions, a little over 600 kilometers downrange. And then that will be followed shortly after that by SECO 1. That is second engine cutoff 1. That is when the Merlin vacuum engine will shut down, and it's called SECO 1 as there will be a second reignition about 50 minutes after flight. But still a ways to go before that one. Right now, the second stage continuing to burn, it looks like right on target, just based off of the data that you see in the bottom right of the screen there.
Yes, and it's worth noting that this is the first of 2 second stage burns tonight, which is usual on these Starlink missions. After SES-1, the first stage will coast for roughly 45 minutes before igniting its engine for a 2-second burn and then coasting for 12 minutes and deploying the Starlink satellites.
There we go. The first stage now just 5 kilometers off the deck of the drone ship here. And now you'll see it get ready to land. You can kind of see the lights of it a little bit, it looks like, through the booster grid fins there. But we'll definitely get a good view in a couple seconds once those landing engines ignite, and there they go. The grid fins, you will see them start moving as it helps steer it towards the drone ship deck in the thicker parts of the atmosphere here. And we've got the double view here from on board and on the drone ship. We have landing leg deploy and touchdown. That is now the second booster in 1 week to complete its 17th flight and counting.
And that was SpaceX's 228th booster landing and 154th consecutive booster landing.
Absolutely beautiful as always. What a level up. And Julia, I'm sure that had to be beautiful where you were too.
Absolutely, it was very beautiful. And even from the north of the launch site, it was a wonderful rumble.
Oh yeah, the rumble never gets old. Although again, as we talked about, sometimes the weather, the humidity, and thicker clouds might actually make it a little more intense. But it's always still intense when you get that rumble, right? And it's still,
Absolutely. That is one of the best parts of living here is I don't even mind being woken up by a rumble.
and I'm sure you don't mind this at all as well, being able to get a fantastic street shot, which we now have on screen. This was a shot from Julia from the Max Brewer Bridge, right?
That is where I was tonight. Yep.
Absolutely beautiful. And you can see, I love the part where you can see where it kind of poked through the cloud right there and right around about where we saw that vapor cone, the shock cone there. Absolutely beautiful shot, Julia, as always. If you're not following Julia, you need to be following her. You're missing out on some great photography and awesome stuff coming in, especially from the port. And again, you can see her Twitter handle, or X handle, excuse me, on screen there on the top right.
It's a Twitter handle.
Wix, I believe Max likes to call it.
Yeah, I also just have to say, I love these streak shots where you can see the reflection of the launch in the water as well. It's always so gorgeous.
It is. And that's another thing of seeing them in person that you get is you do kind of, sure, you look up at the rocket, but there's something also just about looking down and seeing the entire area lit up, especially at night, with just the glow from the engines and that particular dot in the water of the brightest portion. It's absolutely beautiful. Yes, to quote a movie Adrian won't get, it was beautiful. And again, Das's favorite view now on screen with the empty launch pad. And I do want to point out something that was mentioned in our launch roundup article this week. At this current launch cadence that we've now seen, Space Launch Complex 40, which we're looking at right now, would be able to support over 90 launches in a calendar year. And a reminder, that doesn't count Launch Complex 39A, and that doesn't count out in Vandenberg Slick 4 East.
Yeah, that's obviously somewhat idealistic, but based on this turnaround, which SpaceX has been doing somewhat consistently, they would be on track for over 90 launches from the single pad next year.
Absolutely nuts. But hey, if Elon wants 144 launches in a year, you're going to need a pad and a fleet, especially out in the ocean in this case, that can keep up with it. And so far, it looks like it. Now, we did get some, again, really generous support that still came in right around T0 and during the launch. Jake Winlow, thank you for gifting 5 Red Team memberships. Apocalypse Cow, thank you for gifting 10 Red Team memberships. TS6000, no message, but still with the support, which we greatly appreciate. Rocket Prophet, thank you for upgrading to a Red Team membership. Renee Gonzalez Jr., thank you for becoming a PadRat member. And Jim Cavett, thank you for gifting another Red Team membership. Absolutely fantastic. Also fantastic, the team that joined me here tonight for the launch. Julia Bergeron from the field, thank you so much for being on tonight.
Thank you for an entertaining stream tonight. And I want to thank all of our viewers and members and supporters on Twitter. Because without you, we can't do what we do.
Whatever you may call it, we do appreciate that support. Thank you as well for joining us from the studio tonight, Trevor Sesnick.
Yeah, of course. It's always exciting when on a mission 6-18, the booster becomes -18.
Oh, that's a really good point. Love when that happens. You know me, I love when these aren't just your ordinary Starlink launch. And they do be hitting different, which reminds me of a shout out as well to Max Evans, who was at the press site there, operating that camera, tracking the launch for us, did a fantastic job, and thankfully didn't have to hear him mention anything about stubby nozzles. And thank you as well to Pat O, who's behind the scenes pushing the buttons, pulling the levers, bringing up all those graphics, switching between camera views, and all the million other things that you don't get to see on stream, but still makes it look clean on air as possible. So thank you, Pat. And I have been Sawyer Rosenstein. Thank you very much for watching. Reminder, once this booster comes back into port, you'll be able to see it on our Space Coast Live 24/7 feeds, which you can find on our channel here. You can also go to nsf.live/spacecoast to see it as well. And there's a quick view of it. And we can send you over there if you want to continue to enjoy some of the Space Coast beauty. But for now, that's all for our commentary tonight. Thank you for watching, everybody. And as Das likes to say, later, nerds.
And here we go.
R68 chamber pressure looks good.
Doubling up. Roger, with planet. Water towers, fly!
Tango down to nominal.
Flight downside FTE off. Bring in FTE off. It's orange!
Oh my god! Oh my god!
Decollage. Put that in the big bag,
343 unfolds to go.
Indeed. We rise together, back to the moon and beyond.
If the methane would be igniting in the flare, correct?
Yikes. Keep that. We don't need any more of these.